Yes students, welcome back to the next video lecture. I think in the last lecture we have discussed the concepts of intervals. Students, basically there are two types of intervals. First is open interval and second is closed interval. In open interval endpoints are not included, whereas in closed interval endpoints are included. So 1.3 students, we have done up to sum number 7. Now today first we are going to define universal set. Students, what is a universal set? Now all of you concentrate. A reference set with respect to which all the other sets are defined is called a universal set. A reference set with respect to which the other sets are defined, students, is called universal set. Or in simple terms I can say a set which is used as reference set in the study of set theory, students, is called a universal set, and that set, students, is usually denoted by capital U. Now what universal set would you propose for each of the following? The set of right triangles, and second the set of isosceles triangle. Okay students, question 8, what universal set would you propose for each of the following? We have a set of triangles and we have set of isosceles triangle. Then for these two sets, the universal set U can be set of all triangles. For these two sets, students, the universal set can be the set of all triangles. That we need not write, students, you can easily understand. So for these two sets, the universal set U is equal to the set of all triangles. Now students, the ninth question, given sets A is equal to 1, 3, 5, B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8. Which of the following may be considered as universal set for all the above three sets A, B and C, students? The correct option is 3. The set of you can say integers from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So students, basically universal set is the reference set which is used in the set theory, and with respect to universal set, students, all the other sets are defined. Now students, the next topic. The next topic is of set operations, and before set operations, students, we have to study Venn diagram. Now say students, Venn diagram. When I use this words Venn diagram, all of you are very well aware of how to draw a Venn diagram. So students, if I want to draw a Venn diagram of set of elements of any set, and U is our universal set, students, then suppose our universal set is U is equal to 1, 2, 3, 4 and 5, and say our set A is 2, 4 and 5. If I want to represent this in the form of a Venn diagram, our universal set is denoted by a rectangle and set is denoted by a circle. So this is set A. In set A we have elements 2, 4 and 5, and elements 1 and 3 are outside set A in the universal set. So this is how, students, we can draw Venn diagram. You can say the famous logician, I can say, John Venn, he gave the concept of Venn diagram. Now students, the basic set operations. You have already studied how to find union of sets, students. You have already studied how to find intersection of sets. you have already studied, students, how to find complement of a set. Now students, if I come to basic set operations, then the first fundamental set operation is union of sets. Now students, here definitions are not important, but the concepts involved, students, are very, very important. I repeat, students, the definitions are not important, but the concepts, students, involved are very, very important. So the first basic set operation is union of sets. Students, the most fundamental and the first basic set operation is union of sets. Students, how you take union of sets? Say I have set A is equal to A, B, C, and say set B is B, E, and F. Then students, A union B, U stands for union, A, B, C, E, and F. In union, students, we write all the elements of A and B only once. Repeated elements are not repeated in the set. As this is a very well-known fact, students, that in set, elements are not repeated. So in the union of sets, we have elements either present in set A or present in set B, or even a common element to A and B. So if I want to define union of sets, I can say let A and B be any two non-empty set. Then a set consisting of elements either present in A or present in B or present in both, students, is called union of two sets, denoted by A union B, students. So union is one of the most fundamental, students, set operation. Students, union is one of the most fundamental set operation. Now students, we have to study some basic properties of union. This property, students, you need to remember. These properties are used, students, in rider type of sums. These properties are used, students, in prove that type of sums. So students, one must be very careful in understanding and memorizing this properties. So the basic properties of union of sets. This, students, properties we have to write three times to remember. Properties of union of sets. The first property is A union B equal to B union A. This is, students, commutative law. Addition is commutative, students. If you add B to A or A to B, the final answer is same. So we write A plus B, students, is equal to what? B plus A. Same way, students, A union B is same as what? B union A. So students, union of sets is commutative. Then students, associative law. For associativity, we need three elements. A union B, union C is same as A union B union C. So if I take union of A union B with C, or if I take union of B and C with A, the final answer comes out to be same. This is associative law. Then students, A union null set. A union null set is equal to A. So this is the existence of identity element. Null set is identity element for union. You take union of any set with null set, the answer will be the same set. Then A union A is equal to A. A union A is equal to A. This is called idempotent law. Students, these are Greek words. Remember, A union A is equal to A, students. This is called idempotent law. And U union A, U union A will be equal to U, students, because A is a subset of U. Any set A which is considered, students, it will be always the subset of universal set U. So this property, students, you need to write twice or thrice minimum and remember. The next basic set operation is intersection. Students, all of you have studied in your basics standard how to find intersection of two sets. Okay, students, the next concept is, or the next set operation, students, it is intersection of sets. Intersection of sets. Say I have two sets, A is equal to A, B, C, and say B is equal to C, F, G. Then A intersection B is singleton set C. So students, how would you define the set operation intersection? Let A and B be any two non-empty sets. The set consisting of common elements to A and B, students, is called intersection of given sets, and it is denoted by inverted U. The set of elements common to A and B, students, is called intersection of the given sets, and it is denoted by A inverted U, that stands for intersection, students. Now, as we had properties of union of sets, students, same way, students, we have properties of intersection of sets. Properties of intersection. Properties of intersection of sets. Now, the first property is commutativity. A intersection B, students, is same as B intersection A. So A intersection B is same as B intersection A. The second property is associativity. If I take intersection of A and B with C, that is same as intersection of B and C with A. So the next property, students, is associativity. Then, students, null set intersection A is null set, and U intersection A is A. So identity element and law for U. Null set intersection A will be definitely null set, and U intersection A will be definitely, students, A. Then fourth, A intersection A is equal to A. This is again, students, idempotent law. And the last but not the least is distributive law. This we have to understand very carefully, students. A intersection B union C will be A intersection B union A intersection C. This is distributive law, students. The first sign will come in the bracket and the second sign will come between the brackets. This is how, students, we remember distributive law. If I am writing A union B intersection C, then these two signs in the bracket will change to union and this between sign will change to intersection. So the first sign will come in the brackets and the second sign will be the connecting sign between the two brackets. Distributive law, students, one of the most important concepts in prove that type of sums. So one has to be very careful. Now, students, the next concept or the next basic set operation we will do next time. Now, students, we are doing questions of exercise 1.4. Let us do, students, first 4 questions of exercise 1.4. Now, in the first sum they have given that find the union of the given pair of sets. Students, we have to operate union for the given pair of sets. Let us do the question. The first pair is x is 1, 3, 5 and y is 1, 2, 3. Okay students, exercise 1.4, question 1, part 1. Set x is 1, 3, 5 and students set y is 1, 2 and 3. So if I am taking union, I have to take all the elements of x and y once. 1 and 3 are common elements, so we are not repeating. So x union y will be set of elements students 1, 2, 3 and 5. Second, A is equal to A, E, I, O, U. Set A is A, E, I, O, U. And set B is set of elements A, B, C. So A union B will be A, B, C, E, I, O, U. The first set is set of vowels, where A is common, so A we don't write and B and C we add. Then students, the third pair, A is equal to X such that X is a multiple of 3 and it is a natural number. X is a multiple of 3 which is a natural number. So multiples of 3 and natural number starts from 3, 6, 9, 12 and onwards. So the elements of set A are 3, 6, 9, 12, 15 and onwards. B is equal to X such that X is a natural number less than 6. Natural number less than 6, so it is set of elements 1, 2, 3, 4, 5. If I want to operate students A union B, then 1, 2, 3, 4, 5, 6, 9, 12 and onwards. Our union will be an infinite set because set A is an infinite set. Read X such that X is a multiple of 3 and it is a natural number. Now multiples of 3 in terms of natural number starts from 3, 6, 9, 12, 18, it goes up to infinity. So union correspondingly will be also an infinite set. Okay students, question number 4. A is equal to X such that X is a natural number and 1 less than X less than or equal to 6. Okay, now all of you concentrate students. X such that X is a natural number and 1 less than X less than or equal to 6. So if I operate the fourth part, set A consists of 2, 3, 4, 5 and 6. 1 is not included. And B is equal to X such that X is a natural number and 6 less than X less than 10. Natural numbers between 6 and 10 will be 7, 8, 9. So if I want to operate union students, A union B will be set of elements 2, 3, 4, 5, 6, 7, 8 and 9. Because none of the elements are common. Then fifth, I think you can do on your own. A is 1, 2, 3 and B is null set. When you unite A with null set, the answer will be A. So the answer is 1, 2, 3. I think that all of you can do on your own. Now students, question 2. If set A is set of elements AB and B is equal to set ABC. Main question 2. Set A is set of elements AB and set B is equal to set of elements ABC. Is A subset of B and what will be A union B? These are very simple questions. Now all of you have studied students the definition of subset. If every element of A is an element of B, then definitely students A is a subset of B. every element of A is an element of B, so A subset B is true according to the definition of subset. Now if A is subset of B, definitely A union B will be B. You can check if I take union of B and A, my answer will be, students, B. Now question 3 is a part of question 2. If A subset B, then what will be A union B? If A subset B, then A union B will be definitely B. We have shown here, students. So I did not do the third sum, students. I think all of you can very easily, students, do the third sum. Okay, students, I think all of you have understood. Now, students, question 4. Let us do question 4. Exercise 1.4. Set A is set of elements 1, 2, 3, 4. Okay, set A is set of elements 1, 2, 3, 4. Set B is set of elements 3, 4, 5, 6. And set C is 5, 6, 7, 8. And set D is 7, 8, 9, 10. Okay, students, this is given to us, and based on this we have to answer the questions. Now there are some 7 parts. I'll be doing any 3 parts. Remaining 4 parts, students, I am assigning as homework, which I wish all of you must do on your own. So I am doing part number 3, then I am doing part number 6, and then I am doing part number 7. Okay, the third part is, students, to find B union C. To find B union C, we take every elements of B and C once. 3, 4, 5, 6, 7, 8. Repeated elements are 5, 6. We don't include again. Then 6th part, A union B union D. First, let us find A union B. So A union B will be 1, 2, 3, 4, 5, 6. Its union with D. 7, 8, 9, 10. So this union will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And B union C union D. Okay, part number 7. B union C union D. I am operating B union C. Already I have checked. It is 3, 4, 5, 6, 7, 8. And its union with D, I am to include 9 and 10. So this will be 3, 4, 5, 6, 7, 8, 9, and 10. That's all, students. So these are very easy questions, but one element less or more is always considered wrong. I repeat, students, one element less or more is always considered wrong. So do the remaining parts in homework. If you have any doubt, you are most welcome to discuss with me. Now, students, questions 5 and 6. Now we are doing questions 5 and 6. Now 5th is same question 1, but instead of writing union, students, we have to write intersection. Okay, now students, question 5. The first part, now directly I am writing answer x intersection y. Now the common elements to x and y are 1 and 3. You can easily check. The sets are given. That is why, students, I am directly writing the answer. Then in the set A, second part, A, E, I, O, U, and in the set B we have A, B, C. The common elements to set A and B is only A. Singleton set A. So part A intersection B will be singleton set A. Now the third, okay, here I am writing A and B so that you can understand better. A is a multiple of 3 and definitely this is a natural number, and B consists of natural numbers less than 6. So 1, 2, 3, 4 and 5. The common element to A and B is only 3, that is singleton set 3. This is also very clear, students. Now fourth, A is equal to X such that X is a natural number 1 less than X less than or equal to 6. So A will be 2, 3, 4, 5, 6, and B is equal to natural number, means X such that X is a natural number 6 less than X less than 10. So 7, 8, 9. Definitely A intersection B is null set. Students, the set for which intersection is null set are called disjoint sets. Let it be any number of sets. Say for any two non-empty sets A and B, if A intersection B is equal to null set, then students, set A and B are called disjoint sets. This is a concept which we will be studying in the next lecture. And fifth, we can do orally. A is set 1, 2, 3 and B is null set, so A intersection null set will be definitely null set. And if it was union, then A union null set, that will be definitely equal to A. Okay students, the sixth question, again here we have to write intersection of the sets. Set A consists of elements 3, 5, 7, 9, 11. Set A consists of elements 3, 5, 7, 9, 11. Set B consists of elements 7, 9, 11, 13. Set C consists of elements 11, 13, 15. And set D consists of elements 15 and 17. Okay students, here total there are 10 parts. So students, I am doing all even parts here and odd parts I am leaving as homework. Even parts, so 2, B intersection C. Common, what is common between B and C? The answer is 11 and 13. And that all of you can easily understand. Fourth part, A intersection C. Come on, what is common between A and C? The answer is singleton set 11. Okay, sixth part. It is A intersection B union C. So what is A? 3, 5, 7, 9, 11. Its intersection with B union C. B union C will be 7, 9, 11, 13 and 15. So what is common between these two sets? The answer is 7, 9, 11. Then students, eighth part. It is A intersection B union D. A intersection B union D. What is A? 3, 5, 7, 9, 11. Its intersection with union of B and D. 7, 9, 11, 13, 15 and 17. What is common between this? Then the answer is 7, 9, 11. Okay students, so I leave the remaining questions of part 6 as homework, and I hope students, all of you can easily do it. So here we conclude the lecture students. In today's homework, write properties of union and intersection thrice and do all this